Hello, in this video we're going to take a look at solving a quadratic using the square root method and using completing the square. Alright, so using the square root method is a method that works really good if you only have just one x anywhere in your problem. Doesn't matter whether we're talking about a squared, x to the first, doesn't matter. If you only have one x, which this first example we've got the quantity 4x plus 2, quantity squared, equals 4. We've only got one x in that entire problem. So the goal of the square root method is to isolate that one x by just working outside in. So here we have 4x plus 2, quantity squared. So to get rid of that square there, we're going to take the square root. If we do it to one side, we have to do it to the other. Now, when we take a number, any number, we square it and take the square root, technically what we end up with is the absolute value of what was inside the parentheses, which could be positive or negative, but that absolute value is going to make it positive. So what we're going to do is we're going to put plus or minus. Anytime you're looking at an even root, taking an even root, a square root, a fourth root, anything like that, when you take that root, you've got to put plus or minus on it. All right, so the square root and the square are going to, with that plus or minus, cancel. And we're going to be left with just what's inside the parentheses, 4x plus 2. And then on the right hand side, we get plus or minus the square root of 4. Well, square root of 4 is 2. And you can leave it like that, or it may be easier to go ahead and split that up and write that as 4x plus 2 equals a positive 2, or 4x plus 2 equals a negative 2. And then solve those linear equations. We're going to subtract 2 and divide by 4, and we get x equals 0 for the first one. When we subtract 2 and divide by 4 on the second one, we're going to get x equals negative 1. So those are our solutions, 0, negative 1, and this did, if we had multiplied that all the way out, we had an x that was squared, and so we would get two solutions to that quadratic equation. All right, now let's look at a completing the square problem. All right, here we have x squared plus 4x equals 12. When we're completing the square, we want to get our equation written in the form of x squared plus bx equals c. And I put a big space between the bx and the equal sign here because what we're going to do is we're going to turn this into a perfect square trinomial. Now, I do want to point out something real quick. This is a 1x squared. There is no coefficient on our x squared. That has to be our starting point. So if there is a coefficient there, and we're going to look at an example in just a minute that has one, we're going to have to divide that out to get rid of it. All right, to make this a perfect square, remember perfect squares always come in the form, if we take a perfect square like x plus 5 and we square it, that's going to always be x squared plus 10x plus 25. Now we have a special relationship that we see here between that 5 and 10 and 25. Think you see the pattern? Well, let's see if it holds up if we look at x minus 3 squared. When we square that out, we get x squared minus 6x plus 9. Does the pattern still hold? What we're doing is we are looking at it doubles to get the middle coefficient, and we square it to get the last coefficient. So negative 3, if we double that, we get negative 6. If we square it, we get a 9. 5, if we double it, we get a 10. If we square it, we get a 25. So that's what we're going to do, but we're going to go reverse. So we want it to be, we're going to take half of this, so our number in the middle is our b. So what we're looking at is whatever's in the spot of either this 10 or this negative 6. So instead of doubling it, going backwards, we're going to take half of it and then take that number and square it. And we're going to add that to both sides so that we get something in the form of a perfect square trinomial. Well, if we add something to one side, we got to add it to the other. All right, so here we have x squared plus 4x equals 12. So we're going to get x squared. I'm going to go ahead and write it that same way where we've got it a little bit of a blank. Well, we add to one side, we have to add to the other. So our 4 here, we are going to take half of it, and then we're going to square it. So half of 4 is going to give us, that's a positive 4, so half of it is going to be a positive 2. And when we square that, we're going to get a 4. What we add to one side, we have to add to the other. We want it to be squared just like these were. So we get x plus 2 squared. So what we've done is we have found our perfect square and factored it as a perfect square on the left-hand side. X squared plus 4x plus 4 is a perfect square trinomial, and it's going to factor to x plus 2 quantity squared. On the right-hand side, we're just going to simplify that, add it. 12 plus 4 is 16. And then now we're exactly where we started the previous problem. And so we want to take the square root of both sides. Don't forget your plus or minus. So x plus 2 squared, square root is going to be x plus 2 equals either a positive or a negative. Square root of 16 is 4. And the last one I split up, I'll leave this one together just so you guys can see how that works. I always put, when we have x plus 2 equals a plus or minus a number, I always put that plus or minus on the end. So x plus 2, we're going to subtract 2, and then put that plus or minus 4. If this simplifies where it doesn't have a square root in it, like we have here, square root of 16, 16 is a perfect square, and so that square root goes away, we can write this, and this is going to be negative 2 plus 4. So negative 2 plus 4 is 2, and then negative 2 minus 4 is a negative 6, and so that is our solution set. All right, let's look at another one using completing the square. This one, we've got 5x squared plus x minus 1/4 equals 0. So that 1/4 might be the intimidating part, but the first thing that we're going to get rid of is that 5 out front. So we can only use completing the square if we have a 1 in front. And so we got to get rid of this 5. And the way we're going to do that is we're going to divide everything by 5. So 5x squared becomes x squared. I'm going to go ahead and write this as a fraction. So instead of x over 5, I'm going to write this as 1/5 times x. And then 1/4 divided by 5. So 1/4 divided by 5. You can use the inside and outside. That's going to be 1/20. Our outsides gives us our numerator, 1 and 1, and our insides give us our denominator. So this is going to be minus 1 over 20. All right, we want to, now we've gotten rid of that coefficient. Now we want to get rid of that constant, move it to the other side, and get this set up for our completing the square. So we're going to get 1/5 x squared plus 1/5 x plus a blank. We're going to add 1/20 to both sides. All right, we're going to take our 1/5 and we're going to take half of it. Well, taking half of it is the same thing as multiplying by 1/2. So 1/5 times 1/2 gives us 1/10. And then when we square that, we get 1 over 100. 1 squared is 1, 10 squared is 100. So this is going to factor to x plus, same sign that we have here, 1/10 quantity squared. And then on the right hand side, when we add that, we got to get a common denominator. And let's see, 20, we need to multiply top and bottom by 5. So we get 5 over 100 is what we get with 120 if we get that common denominator, plus 1 over 100 gives us 6 over 100. And we can reduce that 6 over 100 reduces to, actually, you know what, I'm going to leave it like that for just a minute. We'll reduce it in just a minute, but let's take, since that 100 is a perfect square, let's go ahead and take our square root here on both sides. So x plus 100 squared, take the square root of that, we get x plus 1/10 quantity squared. We take the square root, we get x plus 1/10. And then on the right hand side, 6 is not a perfect square, so we're going to just write that as the square root of 6. And there's no perfect squares that go into it. And then, but the square root of 100 is a perfect square. That's going to simplify to 10 in the denominator. And then just like we saw in the last one, when we move this, I'm going to put it in front. So when we subtract 1/10, we get negative 1/10 plus or minus the square root of 6 over 10. If you want to, you can go ahead and write that as a single fraction, negative 1 plus or minus the square root of 6 all over 10. We do get two solutions there, the positive and the negative, to our original quadratic equation. Let's look at one more example, just so we can get a little bit of extra practice. This is something students often struggle with. All right, our next example, we've got 12x squared plus 17x equals 7. So just like we saw in the last one, we cannot have that coefficient out front, so we're going to divide everything by 12. 12x squared divided by 12 is going to give us x squared. 17x divided by 12 is 17 over 12 times x. And then on the right hand side, we have 7 over 12, doesn't reduce. I'm going to go ahead and get this in form, ready to go. We're going to take half of that middle coefficient, 17 over 12. So 17 over 12 times 1/2 is going to be 17 times 1 is 17, 12 times 2 is 24. So we're going to get 17 over 24. And then we want to square that. So if we square 17, we get squaring 17, we get 289, and then squaring 12, we get 144. All right, so factoring that left-hand side, it's always going to work out to x, whatever the sign is on our b term, times half of that b term squared. And on the right-hand side, we do need to get a common denominator. All right, so if we square 17 over 24, we get 289 over 576. So we want to add that to both sides. And then we are ready to factor that left-hand side. Remember that perfect square trinomial that we created will always factor to our variable, the sign we have on our first term, and then that half quantity squared. On the right-hand side, we do need to get a common denominator. 12 and 576 is going to have a common denominator of 576. So 576 divided by 12 is 48. We're going to multiply top and bottom here by 48 to get that common denominator. And 48 times 7 is 336. Plus 289 all over that 576 gives us 625 over 576. If you want to use your calculator to help you with this part, you can. These numbers are a little bit bigger than we normally see. X plus 17/24 squared. We can take the square root of both sides. Make sure that you include that plus or minus. On the left-hand side, we'll get just what's inside the parentheses, x plus 17/24. On the right-hand side, 625 is a perfect square. This is going to give us plus or minus 25 over 24. And then we can subtract 17/24 from both sides. And negative 17 plus 25 is 8. And negative 17 minus 25 is 42. Both of those fractions are going to reduce. 8 over, we've got a negative in this one. 8 over 24 reduces to 1/3, and negative 42 and 24, those numbers are both divisible by 6. So if we divide by 6, we get negative 7 over a positive 4. And will give us our solution set. So 1/3 and negative 7/4. This is one I probably would have preferred to use the factoring on it. All right, I'll see you guys next time.